right, so let's take a look at this F201 project here. So we're going to download case1.zip. It's really small, only 3 megabytes, and you can verify the hash values. That's a good thing to do. So let's take a look in here. I've got case1 unzipped there, and here's the case1.zip file. I already unzipped it previously. Now to check a hash value, we used to use something called hashcalc, but it's been gone for a long time. Now we can just use PowerShell. Microsoft has finally added some useful stuff in their command line, and PowerShell has, among the other things, it has the ability to calculate hashes. So I open this. Now this is my home folder. I have to go into Downloads, and then I can do a directory of case star.star, and it'll show me I have this thing called case1.zip. So if I want to verify the hash, I'd like to get the SHA-1 hash. So that is get file hash algorithm SHA-1, and you only need to type the first few letters of something, and when you hit tab, it will complete, but it's really slow compared to the bash shell command line, because you get used to this. Everything in Windows is always super slow. It's an incredibly inefficient operating system, especially if you get used to the Mac or Linux or Unix. You have to lower your expectations a lot, unless you get a lot of power. Like when I make a cloud machine for Windows, I need to give it 16 gigs and 4 processors to get the same thing I'd get on Linux with 1 processor and 1 gig. Anyway, you get used to this. And now the input file is algorithm, just the name of the file. Okay, so it's going to be case1.zip. There we are. That should do it. Yep, that gives me the SHA-1 hash, and see it ends with C1D, and it should end with C1D, so I know it's okay. And the flag is the first part of that. So that's the first thing, and this is something you should be in the practice of doing, verifying a hash value of your evidence. This is how you make sure it's intact. I remember many cases I worked on, we always had to make a perfect copy of the evidence for the prosecution and another copy for the defense, and this was a big deal. And the hash value is one way to make sure, if you have electronic evidence, that that's what you got. So then you unzip it. All right, now we create an autopsy case, and we're gonna, yeah.
The hash value is the code that, for example, is provided when we download applications and you want to verify the originality of that file?
Yes, although that process is considered pretty old-fashioned and insecure, modern applications have a signature, which is a more formal way of doing the same thing. But yeah, in the old days, they would have a hash value, and you'd verify the hash value. Now, the problem is, this happened to Mint Linux. Somebody hacked into their website, put malware in the image, and changed the hash file on the web page. That's the problem. That's why it's not considered as good as a signature. A signature is actually verified by a trusted third party. So it's more reliable than a hash value, but a hash value is available as an integrity check. And it's typically what forensic tools use. You take some evidence, you put it in a file, you put a hash value, and then you can make copies. Because remember, you never work on the original evidence. You lock that in a safe because you need to take that to court. You work on a copy of the evidence, but you know your copy is correct because of the hash value. You make as many copies as you want, and if the hash value matches, that means every bit is intact. All right, so let's start an autopsy case here. And give it a name and a directory, case number. Host doesn't matter. Data source, we're going to have disk image or VM file. Okay. All right. All right. New case. F201. I'll call it Fall 24. I probably have an old one. Then next, and I don't really need anything here on. I don't know if I even need to fill that in, but I'll just give it the same thing and then finish. All right, now it's going to spend about a minute just making an empty container of the database to prepare to stick the evidence in there. A truly great program. This course used to be much, much more difficult. We used to have to use about 10 or 12 open source tools. Each one would do a little bit. This gives you one container for it all.
The tools that are mentioned in the text are mostly freeware, mostly
I think so. I think it mentions FTK and Encase, and those are expensive. That's why we can't use them. They cost too much. But
But some of them are free.
I think so, yeah. But it turns out in practice, Autopsy pretty much replaces them all. The only thing we're really going to need in this class is Autopsy and Wireshark until we get into a little incident response, and then we'll use Velociraptor. But Autopsy and Wireshark are pretty much enough to do almost everything. For some reason, Autopsy does not analyze network traffic. It could, but they haven't added that into it. For that, you have Wireshark. And to be fair, if I was making it, I wouldn't bother because Wireshark has been around for years and it's huge and very powerful, and it would be a total waste of time to attempt to duplicate that. It has a very active community, constantly adding new features. There's no point even competing with it. Microsoft does make their own thing called Netmon, but it's ridiculous and nobody uses it unless you're a total Microsoft fanboy. Everybody uses Wireshark, which is much more powerful. But there are some people that are totally bought into the Microsoft Kool-Aid and they use the Microsoft version of everything, even when it's terrible. Like I remember they used to say when Bill Gates was the CEO, you'd be listening to your iPod, and when Bill walked through, you had to hide it and pretend you were listening to a Zune. I don't know if you remember Zune. Zune was one of Microsoft's many failed products, imitating another product that it couldn't compete with. Anyway, so now...
Well, it's much smaller than the iPod.
Might have been. I never had either of them. But I just heard it was the Microsoft alternative, and he made his family use the Zune. And that's when I knew he was nuts. I mean, you want the truth if you want to succeed. You don't want to force the people around you to lie and tell you something's good when it's not good. At least that's what I think. But anyway, it's... All right, so now it's a disk image, which is true. And now, when I unzipped it, that thing broke up into several files, and the only one we want is the rhinousb.dd. So it's browse, go into the downloads folder, which is a little hard to find. I'll go here into my home folder, and download should be somewhere here. There they are. And then I unzipped it into this case 1 folder, and here's this thing called rhinousb.dd. That's what we want. By the way, DD is disk duplicate. That's a flat copy, not compressed. That's the open source format. That's going to be a copy of some data, and it's going to be exactly as big as the original. So you normally don't use it, but in this case, it's a small amount of data, so it's okay. And by the way, we could fill in these hash values and then be recording what we should have. I don't have them, but it would not be a bad practice to store that with the data. Anyway, now, let's see what I said here. In the configure ingest, select all and next. Okay, I want to do all things here. Select all. Do all possible analysis and next. So that would take a long time, except it's a really small data file, so it won't take too long. If we had a full 500 gig image, it would take a long time. And that's why when you're doing serious forensic work, you get a really powerful machine with many processors, tons of RAM, and lots of fast storage. But for this course, we're just using simple test cases that can be run on, a weak machine, like just a virtual machine like this with only a couple gigs of RAM. All right, I clicked finish, but it didn't listen to me yet. Finish, I say data is, files are being analyzed. And when it lets me see, down here you'll see it's analyzing files, and see it's there it jumped all the way to 64% all at once. But this is running through all those checkboxes. They're trying all kinds of different ways of analyzing it. So even though it's not done, some things are going to appear here. You're going to see data sources, and here's Rhino USB DD. So in here it's going to have some information about it, even though it's still analyzing and adding more. So you have some orphan files. There's 0 of them. There's one found in unallocated space. Therefore, it's a deleted file recovered. That's, so there is, and when it finds a file in unallocated space, it gives it a name, unalloc, and then some numbers. So if you click on that, it'll show you what's there. And here you see sorry, 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 sorry. So there was a file at one time that just had the word sorry many times, and it was deleted, and this looks like a fragment of that file left on the drive. So nothing interesting, but anyway, it did recover a deleted file. And now, All right, we might as well go down to images by extension. So let's go File View, File Types, by extension, Images. Well, it's seeing 0 of them, and I think there should be some, so I think I have to wait for it to analyze some more. According to this, I should have 7 images. So that's what you get for trying to look at it when it's not done yet. It says 0, but that's because it's still cooking. So I have to wait a few minutes for it to finish digging out the images out of that file. And there looks like there's some errors maybe. What's this? Yeah, warning me things. This is from today. Local solar server did not answer. Yeah, I don't know what. Here's another thing. No notable hash set, no cyber triage license. Yeah, okay, those look unimportant. Something didn't answer called solar. I don't think you care. But some little part of this program had an error. I'm not going to worry about it. This program is just an amalgam of a bunch of other little programs. Each one of those checkboxes is another program that's sort of built into it, so it's not too surprising that some of them are not working. Well, when Windows gets like this, I wonder if it's just forgetting about me. Let's see if it's doing something. Yep, it's running 100% CPU, and that's Autopsy using up most of the CPU, so it is running. It's CPU limited. So it's digging through those files, trying to reconstruct things. All right. I'll go look at the instructions while we're waiting for this. So what I'm supposed to do is to find some images here. And basically, maybe I'll just stop now. You look at the images, you'll find some JPEGs, and they're pictures of alligators and rhinoceroses and stuff. And you want to find the mother rhinoceros and their child. That's the flag. You turn in that image to show that you found it. And then you can look at the deleted files. We already saw one of them before. If you go down here, you'll find deleted files, 132 of them. So there's a lot of things were deleted. And you see these ones had file names ending in GIF and JPEG. Here's one with somebody died in February. This is like a Word document with writing in it. And so if you go in there, you can sort by file type, and you'll be able to find the one that is a Microsoft Word file and not an image by sorting. And then when you find the Microsoft Word file, it is a diary, and you have to read the diary to find the answers to these questions. So this is something I have students complain about, but the fact is, this is often the case. You have to read through a lot of text. And reading through long lists of files is something you get used to in all forensic work. I remember at first I sort of rebelled, and then I got used to it, reading through long lists of things, looking for the ones that aren't right, the ones that don't fit in. Your tools can sort only so much. At some point, you just have to read through it all. I don't know if this is still true, but I was told years ago that one big job in security was having to read everybody's email, because companies had to filter their email. Because if somebody did something awful in email, like something racist or sexist or stealing company property, you wanted to know. And generally, this was just a job given to some low-level security guy, read all the email going out. Anyway, so you get used to reading through long lists of things.
Is somebody thinking of implementing some sort of large language model to...
Yes, I bet these days they're probably doing it that way. Yeah, because you sentiment analysis, that would save you so much time. Just have a large language model, decide that 90% of it is not anything interesting. That's what I would do, yeah. I'm sure that would be a good use. And then, all right, anyway, now it's finally done, so I should be able to find, there's the 7 images, good. So there we are, and so you click them, you'll see the image down here. There we go. Theoretically, there it is. This is an image of an alligator or something, crocodile. And then if you go down to the deleted files, there's the 132 deleted files. And right now you have a lot of modified time and created time and stuff there. But over on the right somewhere, you will have MIME type. There, this will tell you, the extension is not bad either, but the MIME type will tell you what type of file it is, and you should be able to sort by that. All right, it looks like it's not working for me, which is disturbing. As they change Autopsy, sometimes different things change and don't work. Sorting by extension will work too. The DOC extension will give you the Word document. as well as the MIME type. That's a little disturbing, and it's something you get used to. As they change versions in autopsy, things vanish. Even good things vanish and other things come back. It's kind of disturbing. So if you can't sort by MIME type, sort by extension, then you'll find a document, and down here you should be able to get a lot of stuff to read. This is the artifacts, and here's the text. Yep, and there you go. Text to read, she died in February, and so on. And one thing about these autopsy is it's not very convenient. You might find it easier to just copy all this and put it in Notepad to make it easier to read and easier to scroll through. This viewer is okay, but it's not great. Anyway, so that's what I wanted to show you. That's a little bit more like a real case. You have a few more files to dig through, and that's F201. Let me stop this recording.